Alright, hey y'all, it's Miss Warcow with some notes today on phosphorus and water cycle. Alright, so I'm making this video in anticipation that Friday may be a possible remote learning day, so I wanted to flip-flop which order we were doing our particular topics in, which puts us at topic 1.6 and 1.7 today, phosphorus and water cycle. On Canvas, I will have a biome and nutrient cycle check, all right, just to review some things from the previous units, or previous topics, excuse me. This will be an optional assignment for extra practice if you would like, okay? So we're going to be looking at reservoirs, sinks, and sources today of the phosphorus and water cycle. We're going to look at how these cycles are different from one another, all right, and what they're, how humans can interact with these cycles. So let's start. This is not a part of the note sheet that I'm going to link online, but I am going to use these words, so I wanted to add these in. In a nutrient cycle, which is also called a biogeochemical cycle, a source is something that gives off a nutrient faster than it absorbs it. So for example, in the carbon cycle, which we'll talk about on Monday, combusting fossil fuels is a source of atmospheric carbon. All right, it gives it off. A sink absorbs and stores a nutrient long term. All right, so when we talk about, again, the carbon cycle on Monday, oceans absorb carbon dioxide. That makes it a sink. A reservoir is just where you can find that nutrient. It might be in a source or a sink. It's just where it is present. Okay, so let's start our conversation with the phosphorus cycle. So this is a cycle that we don't really go over a ton in biology. For this one, we're not going to focus so much on the steps, but more why it's different. So let's look at why phosphorus is important to people and animals and all living things, really. Phosphorus is a part of all nucleic acids. All right, remember our sugar phosphate backbone of DNA and RNA. It's also in ATP and ADP, which is how cells use energy. All right, so phosphorus is going to be used in those organic molecules along with other proteins that are used to build things like bone and muscle and stuff like that. Okay. So the main reservoir, so where we're going to primarily find phosphorus, is going to be in rock and sediment. Now, what makes the phosphorus cycle really unique compared to the other cycles that we're going to talk about is there is no atmospheric step. So there's no gaseous phosphorus. There's no phosphorus in the atmosphere. All right. As far as the steps are concerned, the only step I would expect you to know that relates to the phosphorus cycle is this step that's called assimilation. We're going to talk about that with the nitrogen cycle as well. Assimilation means it just is taken up. So with plants, they're going to assimilate phosphorus that was in the soil, take up through the roots, it becomes a part of the tissues. We are not plants, we're consumers. We get our phosphorus by eating other stuff. Decomposition leads to mineralization. That's another step you may need to know. All right, mineralization is just you take something organic, okay, like this horsey, and as it decays, it is converted back into inorganic phosphorus by decomposers like bacteria. All right, so because there's no gaseous step and because the phosphorus cycle really relies on erosion and weathering, phosphorus cycle is going to be the slowest of the matter cycles. It's going to take the longest for that phosphorus to move from reservoir to reservoir. All right. So because it takes so long for phosphorus to go from ocean to land or vice versa, it is typically what's called a limiting factor. We remember limiting factors from chemistry. So that would be like you only have so much of a certain ingredient, so that limits how much product you can make. Same idea here. Phosphorus limits the growth of plants in a lot of different terrestrial biomes. So this particular video, I'll just do a quick synopsis of it. This video is about the Sahara dust. So this is very phosphorus-rich sediment. And every year, winds carry this dust across the Atlantic Ocean, and it's deposited here in the Amazon. And this phosphorus is vital for these organisms here. Remember, tropical rainforest, you have lots and lots and lots of different things, and they're all competing for resources. All right, this phosphorus replaces some of those resources that are being taken. In the rainforest, you also have a lot of erosion and runoff. All right, you have lots of water, lots of rain. That washes phosphorus away into the oceans. This Sahara sand replaces it. All right, and what's really neat is the amount of phosphorus that's lost from the Amazon every year is about the same amount that they get from the Sahara Desert. So it all kind of balances out in the end, which is nice. All right. That's our phosphorus. That's our phosphorus cycle. Excuse me. That's our phosphorus cycle. So it's different because there's no gaseous step. It's really slow. Living things take up phosphorus by assimilation. Organic phosphorus goes back into the soil by mineralization. All right. Our next cycle is our good old water cycle that I know you have learned about for I can't tell you how many years. All right, we have our handy dandy little diagram here. I'm not going to go through every single step. I expect that you already know all of these. You know what precipitation is, condensation, transpiration, evaporation, infiltration, and percolation, and runoff, of course. Didn't forget runoff. All right, so if you need to review those things, I would definitely recommend you do that right now. But let's talk about the main sources and reservoirs of water, along with how does this water go from place to place. All right. So the main energy source of the water cycle is, of course, the sun. All right. The heat energy from the sun, from solar radiation, along with the force of gravity that helps move water to and fro. All right. The majority of our water, so we know Earth is a blue planet. It is a planet that is predominantly covered in water, but most of that water is in oceans. All right. Remember, from aquatic biomes, oceans have high salinity, so that water is not usable by humans for drinking or agriculture. Fresh water, that would be water that we could drink or use for agriculture, most of that is kept in glaciers and ice caps. So it is not accessible by humans. All right. You might be saying, well, why can't we just melt the glaciers or ice caps? We'll talk about why that's a bad idea later. All right. The rest of the water, all right, is going to be in reservoirs in groundwater, soil, surface water like lakes and rivers and streams, as well as, of course, living organisms. You and I are mostly water. All right. So humans can impact the water cycle through our actions. So let's take a look at that. We change the surface of our environments, and we change what things are present or not present. So let's look here at this diagram. We have a natural ground cover. So this is what would normally happen if it were to rain. 10% of the water would run off. 25% of it would infiltrate close to the surface, 25% deep infiltration, and 40% goes back to the atmosphere in evaporation and transpiration. If we look here, if we have 75% to 100% impervious cover, so that would mean like roads, buildings, things that don't let water seep in, we get a much higher increase, we get an increase rather of runoff, 55% runoff, only 10% shallow infiltration, only 5% deep infiltration, and 30% back to the atmosphere in evaporation and transpiration. So we'd have a lot more water just kind of sitting on the surface, and that's going to cause issues. All right. With deforestation, mass deforestation is also going to reduce the rate of which transpiration happens. So as there are fewer plants, as a result of deforestation, less water is going to get back to the atmosphere. Why is that a problem? That is a problem because if that water is not in the atmosphere, you can't have condensation, therefore you can't have precipitation. That is why I've included this little picture here. This is a picture of a Mayan ruin. I'm not sure if it's in Belize or Guatemala. It's in one of those fine places. But one of the hypotheses on why the Mayan civilization collapsed the way that it did was partially their population was growing. They were cutting down these forests, these tropical rainforests, to make room for agrarian land, so much so that it caused or exacerbated drought conditions. So it became too dry. Then you had mass famine, which ultimately led to or contributed, at least in part, to the collapse of that civilization. All right. So these next slides are 4.6, which we actually already talked about with aquatic biomes, but I just want to just come back to it just again really quick with what a watershed is. We're going to remember that everybody lives in a watershed. A watershed is just these areas that all drain to a common outlet. So like this great big pink area, this is the Mississippi River Basin. So it includes the mighty Mississippi River, which is this vein right here. It goes all the way up here through Minnesota, all right, all the way down to the Gulf of Mexico. But it also includes the mighty Missouri River, includes a bunch of these other big old rivers, all right? So everybody in this area, all the water that falls on this land eventually ends up here in the Mississippi River Basin, which is why we want to know what we're doing, because all that water is going to affect this point right here. All right, we are I believe we're in this river basin right here. Now let's take a look. Why are they these shapes? Why are these watersheds these funny shapes? It's because they are following the divide. I want you to remember that the divide is just an area of high land. It's just a ridge. All right, water always flows downhill. All right, so when we're looking at how humans are impacting watersheds, we're going to pay attention to what is uphill and what is downhill. All right, it's going to affect everything downhill because that's where the water is going to roll. All right. We remember that slope determines the speed at which water runs downhill. And we're going to remember that where it's steeper, like in a mountain, water is going to be moving faster. So more erosion will be occurring, which means less nutrients will be deposited. All right, that affects the productivity of that area. In a floodplain down yonder, so this is going to be on flatter ground, all right, water slows. When water slows down, it doesn't have the energy to carry particles anymore. So erosion stops and deposition begins. This is why floodplains like the Nile floodplain and the Mississippi floodplain, this is why they're incredibly productive areas in terms of agriculture, because those sediments have been deposited because this water has slowed down. All right. People impact watersheds. We remember we already actually just talked about this with the water cycle. All right. We change the surface, so we increase runoff and decrease infiltration, and we decrease transpiration. By building dams for energy production, we reduce the flow of water downstream. That's also going to reduce the flow of nutrients. All right. And we also have this idea, we're going to talk about this in much greater detail when we get to Unit 5, but we'll go ahead and talk about it now as well. Excessive fertilizers, like phosphorus from fertilizers or manure, can run off into watersheds and cause this phenomenon called eutrophication. Now, if you already took regular schmegular earth science, you probably already know what that word is, but just know eutrophication is too much nutrients. Too much nutrients in your water is going to cause a problem later on. We'll get to that in further units. Okay? So make sure that you understand the steps of those cycles, including the water cycle. So make sure you're okay with this. Make sure you're okay with where I'm going to find each of these nutrients. Phosphorus is going to be in rocks and sediment. Water is going to be in oceans and ice caps. We are going to, I'm not going to do the FRQ practice today. I want to do that in class. But you may choose to do the optional assignment if you wish, and I hope to see you on Monday.